Today, we make some coleslaw. We actually finished trig today. We finish it. I mean, there's still a lesson where we talk about how do I decide how to use all this stuff, but I'm going to teach that within here a little bit. Learning goal, I'll be able to use the cosine law. I don't even know what the cosine law is. I know, I'm going to teach you. Okay, here's the story thus far. This is like, you know when you watch an episode of television and they're like, last week on CSI, and they tell you what just happened. Here it is, last week in Mr. Todd's math class. If we have a right angle, we're allowed to use the Pythagorean theorem or trigonometric ratios, SOHCAHTOA. If it's right angled, those things are in. And then the question was, what if it's not right angled? You're like, hold on, chapter not over. Chapter now almost over. Yeah? If in a non-right angled triangle, the fancy word for that is oblique, but we don't need that word right now. I'm just going to tell you, there is a word for it. They're called oblique triangles. If we know a side and the opposite angle, that AA, BB, CC thing, if we've got both of those or can get them, we can use the sine law. And here's the question of the day. Alluded to yesterday but not completed. What if you have a non-right triangle and we don't have a side and it's opposite angle? And then they really break it down. They say, what if it's adjacent sides of an angle or all sides and no angles, something like that? Can we still do it? Yes. One more weapon coming at you. Cosine law. Let's rate out the sine law for each of these and see if these have complete AAs, BBs, and CCs. I can see they don't. Yes? I can just look right at it. 62, no B. 45, no A. 40, no C. I'll write it out, but I don't know that it needs writing out. Look at it. It goes 62 over sine B equals 40 over sine C equals, 45 over sine A? There it is algebraically, what I was showing with my highlighter yesterday. Can you see that none of the ratios are complete? I don't have both numbers in any of the ratios. Sine law cannot succeed in this situation. And it's the same in this one. The same situation here. If I was to write this out, I would write, big F. This is new. Little f across from it. Big M, little m. Big T, little t. You're going to want to change your little t's, friends. If I write a little t up there, it's going to look like a plus sign. We don't do that. We draw a little fancy script writing T. Physics people, get ready. Yes? This is how, from now on, whenever you see T in math, you'll see that version of the T. So it doesn't look like a plus sign. So if I try and write out sine law here, I get 8.5 over sine T. I don't have both. Or I can do F over sine 80. Oh, yes. That's what cosine law is going to be. I'm going to draw a line and make a new, but skip all the steps. Yeah, right. Yeah, okay. He's all over what I'm about to do. 10 over sine m. Do you see? It sort of looks like I almost have a pair, but I don't have a pair. Sine law needs a pair. And you'll see all sorts of crazy descriptions about sine law. Oh, if you have this, or if you have that. That's all too complicated. It comes down to this. Without an AA, a BB, or a CC, sine law is powerless. You must have one complete ratio and one other ratio with only one unknown to be able to move forward. All right. So what? Oh, wait. I have a secret for you. Unbeknownst to most grade 10 students, cosine law is actually easier than sine law. But people don't like the look of it. It's scary looking. But when you actually go to use it, it's less work. There won't be any of this cross-multiply nonsense. It's just bang, plug it in. It's very reminiscent of the Pythagorean theorem. Okay? So when you first look at it, don't get intimidated. Just stare at it for a second and realize what has to happen. There it is. Cosine law. It has 3 different versions depending on what side you're going after. I'm just going to put a bracket around this one because I think that's the one that can get you in the door as far as not being intimidated. Because it looks like Pythagorean theorem. Look at that. C squared equals a squared plus b squared. But then this extra little piece here, minus 2ab cos c. I'll prove it, if time permits, at the end. I'll prove that these things are true. Now, these look like they're big and scary, but they're not. They're just rearranged versions of this. Yes? These are the same as those. They've just rearranged to get the angle. You don't actually have to use these. When I was, first of all, when I was a student, and when I was first a teacher, I never taught these at all. I just used those. If you wanted to find the angle, I just used those. And after I plugged everything in, I just isolated for cos A. Okay? So I'm not sure about these. I'm skeptical whether this just makes things look more complicated than it has to. These can just be isolated. And I'll talk about that as we go along. So, how would we use it? Here, take a look at this. Don't get too wound up just yet, okay? Just take a look at the situations that you'll be able to handle. Do you see this situation here with the F? Ooh, not F. Oops. Little a. Sorry, I wrote an F there because the previous one was F. I wrote F there. If I want to go after little a, I can do it with the cosine law, even though I don't have an opposite matching pair. Because cosine law says use this side and that angle. Actually, that's the fancy way to say it. If you have two sides and the contained angle, you're using cosine law. But cosine law also handles situations where all you have is three sides. It looks impossible, but cosine law is unfazed. It can handle that situation as well. But you don't have to remember it like that. You can just remember it like, do I have a pair? No, I don't have a pair. Well, I'm going cosine law. And Mr. Todd says it's not too bad once you practice it. As a warm-up to cosine law. You don't have to really get this just yet. Just see it. This is once, seeing it through. For triangle QRS. What QRS? Oh, I got to draw it. QRS. Here I come. QRS. E. And I'm going to put all these sides and angles on here. I'm going to call this big Q, big R, and big S. Look at me go crazy with the big S, because S is another one of those letters where the capital and the small version of it could get confusing. So, are you with this or no? Which side would be little q if I'm going to use this? The SR, the bottom one, yeah. That'll be little q. That's just our naming convention. And that's how all the formulas are going to be based on. So you always got to name them straight across. And there's big S. Here's little s. Yeah? Did I make them different enough in size that we're not going to get confused? And then R is not a problem. Big R, little r definitely looks different. So here's cosine law. This is me trying to move you towards memorizing it or understanding it and seeing it's not as intimidating as it looks when it starts. Here's me writing down cosine law for side S. Watch this. It's very fascinating what happens here. For side S, you do S squared equals R squared plus Q squared. And then you pause and you savor how familiar that looks. What does it look like? It really looks like the Pythagorean theorem. If you had to memorize this, which we don't make you memorize it in grade 10 anymore. It's so sad. It makes me sad that we don't make you memorize it. But we don't make you memorize it. But if you wanted to be sure about it, you'd go, well, I start with Pythagorean theorem, because that's where it comes from, actually. And then it's got this other term, minus 2RQ cosine big S. Okay? So from a memorization standpoint, it's not quite as bad as it looks. Now, let's say we wanted to go after angle R. I don't memorize those other formulas. I'm going to show you how I get it, and then you can decide for yourself whether what they've shown on the previous page is complicated or not. I'd go, if I'm after angle R, here's the formula I want. I want R, whoops, little r squared equals, can anyone start it off? If I'm going after little r squared.
Inverted cosine.
Oh yeah, I'm going to be inverted cosine in just a second. Oh, he's a step ahead of me. But if I was just doing the formula for little r squared, what would be right here? We're already well on our way to taking the intimidation off of cosine and going, okay, that's where I start. And then this other piece, it's got a -2. And then who sees the pattern? What would the two letters be on the right-hand side? SQ, you're already all over it, yes? Cosine, big R. Okay, so now your R, I hope you're already like, most people, once they see it once times 3, you're like, oh, as crazy as this page was, again, it looks like that puke of alphagettis there. You're like, ah, it's too scary. You're like, hold on, hold on. Let's just line a few of these alphagettis up and see what's going on. Now, here's me going after angle R. Do you see angle R over there? Okay, to get angle R, very slowly. Don't let me away with it. Don't just like, yeah, Mr. Todd must be right. Watch what I'm going to do. I'm going to go, okay, to get angle R, I got to take R squared, but then I'm going to have to subtract off the S squared and the Q squared. Those are going to have to move over to the other side. I didn't leave myself enough room. I'm just going to move that over, okay? I'm not changing anything. I'm just moving it over. Then I'd have to divide by this thing, -2SQ. And then I need some help from a very clever friend. Since I'm finding an angle, I'm going to have to inverse cos it. Yeah? And in action, you could use that formula. You could. We'll give it to you. And if you know what's going on, it's a perfectly good formula. I have no issue with it. But it really is just this one rearranged. It's not really a new formula. It's just a rearranged version of that. But I pause for questions. Is it okay? I'm not making this up, friends. I like cosine law better. I find it easier to plug into. I find it easier to use. I'm not worried about cross-multiplying, any of those things. I'm not just trying to convince you because it's really scary looking and I'm trying to make you not scared. No. I believe it, that cosine law is the easier one to actually use. Okay? Let's do it. Let's do it. Right in with cosine law. It says solve the triangle. Okay. Here's me already teaching tomorrow's lesson. Is it a right angle triangle? No. Sakatoa is out. Pythagorean theorem is out. Right out the door. But who jumps off the bench? Shift change? Sine law and cosine law. Jump on and go, me. I'll do it. I go, okay. Sine law. Hold on. Let me see if you can do this. Do I have an angle with a matching side? No. No, I don't have. I got 52, but I don't have AB. I've got 17, but I don't have angle. I got 20. And no way to get it either because I only have one angle. It's cosine law. It's cosine law. Cosine law is in. Now let's label everything carefully. And I don't like this C on here. Do it on yours too. C. Cookie. Yes? So then, okay. Where's the little c then? Just in case you're out there not quite with me. Where's little c? Yeah. We always go across. Big A. What's little a? How long is it? 17. This is little a. And then this is little b. So if I'm using cosine law, I'm going to be going after C, A, or B. Got to be C. I've already got that. Without peeking. Without peeking. How much can you do? C squared equals, who wants a shot at it? Who thinks they got it? Pause. Yeah? It's the Pythagorean theorem. Mostly. It is. It actually is. It comes from the Pythagorean theorem. Then what do you like? Yes? Big C. Yeah? I'm telling you, it works better memorized than it does looking it up every time. You're actually going to save time memorizing the pattern. And it's the same pattern every time. This is the part I like about cosine law. Now you just plug them in. You just stick the numbers in. C squared equals, what was A? 17 squared plus 28 squared minus 2, 17, 18, cosine 52 degrees. No cross multiply, nothing like that. Just sub them all in. I'll show you one time how to do it. It could be. Yes, I could have copied that down wrong. Good. I'll catch it in just a second. Calculators. Get my calculator out. There you go. There he is. Welcome. Move over there. Yes, I wrote down 18. Nice catch. It was a 28. And with your better calculators, typing in that line, sorry, buddy, that line of mathematics might scare a grade 8 kid, but now you're like, yeah, you just type it all in. And you can see it on the screen what's happening. So you try it to make sure you get the same as me. 17 squared plus 28 squared minus 2 times 17 times 28 cosine 52 equals. I'm going to write all the decimal places just so you can compare with what you typed in to make sure you get the same thing. 486.89 02755. Did anyone else get that when they typed it all in? Yeah, well, you're calculator masters then. You're good. So we've got a triangle whose sides have 17, 28, and 486. That doesn't seem very likely to me. Something's gone wrong. You got a square root at the end, yeah? That's the only wrinkle with cosine law. But I hope when you look at the numbers, it's enough to go, I see it's not. It can't be right. So I got to square root that thing. Now let me show you a new button here. I just want to square root that. I don't want to have to write it all out again. Your calculator's a button for this. Answer button. So I'm just going to go on my calculator. I'm going to go square root. On mine, I have to hit the green alpha button and then E equals sign, and I get the ANS button. Yours might be a shift. Some calculators, it's just a button all by itself. You don't have to shift anything. Handy stuff. Square root of that thing equals 22.1. You like it better in sine law? Yeah, me too. And I'm not lying. Sometimes I do lie. I'm not really attached to honesty. If I'm trying to convince students about something, sometimes I'll be like, oh, no, this is easy, when I know it's not easy. This time, I really believe some people are going to like this better than sine law. And sine law is pretty straightforward, too. Now, this said solve triangle ABC, though. So what's it telling me to do? Get other stuff, too. I've got all the sides now. Now I need to go after an angle. But something's happened here, sine law friends. If you're like, I don't like it better. I still like sine law better. Well, that's fine. Look what's happened here now. I'll get my highlighter out. Stop that. Get my highlighter out. And you go, ah, ha. And sine law jumps off the bench and goes, I'll take it from here, cosine law. It's no problem. Okay? So lots of triangles out there. It'll be sine law, or it'll be cosine then sine. Or maybe sine then cosine, depending on what angles inside you're given. There's only so many cases, though. This can be outstudied. Do you know what I mean by outstudied? Where you're just like, no, I've seen everything. I've done them all. You can't possibly fool me because I've seen everything. Unlike quadratics, where some questions would come out of nowhere. Like, well, what am I supposed to do here? Triangles aren't like that. Once you get all the situations down, you're done. Hey, what's happening here? Uh-oh, something bad is happening. Oh, no. Oh, no. Oh, no. Sorry, folks, it actually shut the program down on me. Yeah, but it's back now. I found it. And I'm ready to do sine law. Okay. Do you want to go after A or B? A. So for me, it's sine A over A equals sine C over C. And if you're totally used to doing these both flipped, it's not going to matter, friends. You can do it either way around you want. So I can do sine A over length of A, which was 17, equals sine 52 over this new number I've got, which is 22.1. Now, I don't want to mess you up. If you're a cross-multiply person, I think you should stay there if you're happy. I want you to notice, though, that I don't really need cross-multiply here. If you do what the note said yesterday, and you put the unknown in the top, you don't have to do the full cross-multiply. You've already got sine A there. You just got to take this sine 52 over 22.1 and multiply by 17. So if you want in here cross-multiply steps, I love it. I love you. Do it. I've got no problem with that. I'm just trying to offer another option. Or notice that when you're doing these, like, wait a minute, if my unknown's in the top, I don't really have to cross-multiply. All I need to do is move this 17 over to this side. But if you're like, don't mess me up. I'm doing fine. Stop doing that. I'm okay the way I am. It's not really saving that much time, really. It's not that big a deal. But I just want to mention that that's true. If you put the unknown in the numerator, you can save yourself a step. So what has to happen here if I'm after an angle, though? I subbed. What's sine A? I don't have an A button. Yeah, I got to do the sine inverse of this whole mess. Of 17 sine 52 over 22.1. You try typing it in. Make sure you and your calculator are friends. I do it all in one step. If you're showing extra steps because that's the way it looks better to you, I love it. Oops. 17 sine 52 over 22.1. Sine inverse, I get 37.3, oops, degrees. Ha, it's good. I'm happy. Did you get 37.3 degrees? Okay. Am I done solving the triangle? No, and the way to check that again is follow my advice and write them on the triangle as you go. Then you'll know when you solve it because you have them all. I got this much space. Is it enough space? Sure. Yeah, it is enough space, isn't it? Because I just go B equals 180 minus the 37.3 minus the 52. B equals Did you get 90.7? So it's a situation where it really looks like it was right angled, but it's not. And if I tried to use SOHCAHTOA on this, my answers would be off because of that, because the angle isn't exactly 90. And actually, the fact that this one's 90.7, we didn't do that on purpose. We just made up a question, and it worked out that it was close to 90 degrees. Okay. Now, friends, this note on purpose does not have a find the angle example. We lay that out as a challenge to you to go, hey, can I take this, what I've seen, and be able to handle angle situations? So there's the other formula. You'll be given the other formula on the test if you want to use it. So try it out and make sure you can do those angle questions. To wrap up the lesson, I don't know, I'm going to do the last slide, and then I'll see if I have time to prove the cosine law. So you can see it's not just something I'm grabbing out of thin air. I can use the math you know to prove the cosine law. Here's your chart, your thinking chart. You get handed a triangle. Is it right angled? If yes, SOHCAHTOA, Pythagorean theorem, and one other thing. Sum of the angles of a triangle. If not, you move to step 2. And if you have an angle on opposite side, use sine law. If you don't have an angle on opposite side, use cosine law. By the way, sum of the angles is still in. That works anytime you want to use it, and we used that in that last example. All right. I have exactly 7 minutes to try and pull off the proof of the cosine law. You're not responsible for this in grade 10. The only thing we do is show it to you so that you don't think we're making up stuff. Yeah? Here we go. See if I can pull it off in 7 minutes. Okay, say you're given a triangle. Here's what we're going to do this time to build a new law. I'm still going to do what I believe Chris was saying earlier, is can't you just divide any non-right angle triangle into two right angle triangles? And that is so true, you can absolutely do that. Once I do that, I've got two sides on the bottom. I've got to erase that B and move it down. Because what I have here is I've got this unknown in here now, making things worse, it seems, because now I don't know what goes there. And then I'll need someone clever to say algebraically what I put here. I'm going to need some help there. And like yesterday, I'll call this H. Now, this is the first big tough part of this. If that's B all the way across that side, and I've made a new side X, what's the one over on the right-hand side? B minus X. That's difficult. Now, once I do that, though, I can do Pythagorean theorem on both sides. I'm going to go over here and go on this side, a squared equals h squared plus x squared. And that's fine. Unhelpful, it seems.
So if I forget everything, can I just do this?
You decide for yourself, yeah. And on this side, I've got c squared equals h squared plus b minus x squared. And it's tempting to give up at that point, and maybe mathematicians did for a couple of centuries. They're like, I don't know what to do. And then somebody said, well, I guess you could go over here and you could expand out these brackets. Unconvinced that that would help. They did the FOIL over there. You know how to FOIL. Yeah, so I'm just going to FOIL over there. So I get this big mess. C squared, now brace yourself. C squared equals h squared plus b squared minus 2bx plus x squareds. Minus 2b. Yeah? Starting to happen. I go back over here and I go, but I don't want h squared in this formula. I go, okay, no problem. Over here I get a squared minus x squared equals h squared, and then I sub that in. See that h squared equals a squared minus x squared? I bring it over and I sub it in over here. Then, those of you who are into this kind of thing, take a long look at that because you're about to do the, mind-blown thing. Here we go. Take a look at that mess because it's getting good. What do you see?
Numbers in math.
Yes? A squared plus b squared, but then there's this minus x squared, and then there's this plus x squared over there. They cancel. Those go. Negative x squared plus x squared, and now I've got c squared equals a squared plus b squared minus 2bx. Ooh, it's really good. It's got only a's and b's, but it's got a random x. I can fix that. Go over here and go cosine of c is adjacent over hypotenuse. Cross multiply to get x equals a cos c. Bring that along for the ride. And sub it in there, and I get c squared equals a squared plus b squared minus 2b times a cos c. Somebody did. Somewhere along the way, somebody went, ha! Ha ha ha! And showed it to all their friends.